Okay, guys, welcome back. Part 2 of complex numbers. And what's weird is that we haven't even talked about an actual complex number yet. We talked about imaginaries. As a quick recap, we talked about how the square root of -1, which, well, past how many years of your math career you couldn't do? It was like, illegal. Something's wrong, can't do it. Okay, it doesn't exist. To where it actually does exist, but we can't visually see it, right? If we were looking at a quadratic that was similar to this, and we said the equation was like x squared plus 1 equals 0, well, there was no solution that we visibly can see. But the solution was this guy up here, right? And by plugging this in, we can see that it will equal 0. Okay, so the imaginary part is pretty spot on for the title. Now, today we are going to talk about what is a complex number, okay? A complex number, let me see, yeah, that looks good. Trying to gauge it off the video. Okay, a complex number is composed of a real component and an imaginary component. So the A part of this format is the real number, okay? And the B would be the imaginary number. Okay? That's what a complex number is. It combines the two together. For example, okay, 7 plus 8i would be a complex number. 7 is the real part, 8i would be the imaginary part. Okay? Now, since we just established that this is a new number that we're working with, I think it might be a good idea to go through all the basic operations, right? Adding, subtracting, multiplying, dividing with these complex numbers and see what we get. What do you think? Sounds like a good idea? Yeah, I think it's a good idea. I'm pretty sure I saw you shaking your head, so yeah, it's a good idea. Okay, first example. Let's go ahead and start with addition. Goodbye. New board. Okay, example 1. Go. Okay. And I do apologize. I don't know if pink's showing up that well. Can you see it off the camera? I don't think I like that. I'm going to use green. So I apologize if this doesn't show up that well. There we go. That might be a little bit better. We're going to add these two complex numbers together. One thing to note. Just because it's parentheses doesn't mean there's something else going on, okay? The parentheses indicate that this is the first complex number. This is the second complex number, okay? Now, when we add these together, we're going to add them by its real parts and by its imaginary parts because they're like terms, okay? 3 and 2 will add together, and we get 5. 5i plus a negative 4i would give me 1i, or we could just say I as our answer. Okay? And that's how you add complex numbers. Not a complex routine, not to use that word again, not complicated, but you just need to make sure, just like in the previous video, simplify the imaginary, simplify the real, and then put them together. Okay? All right. Next example. You can probably imagine that if we are adding, then we got to go to subtraction, right? Let's subtract two complex numbers, and we're going to do this example. Okay. Once again, the parentheses are only there to emphasize that this is the first complex number, this is the second complex number. Be careful. Negatives are a killer in this section, okay? First part, the real. 4 minus 3 is 1. I felt like that was like a first grade question, the way I worded it. Next, -6 minus a -7. Well, if we're subtracting a -7, isn't that like adding? So it's actually plus 7. So we just get a plus 1i or just I. Okay? And there's my subtraction component. Once again, just be careful with negatives. I don't know if anyone wanted to comment on it, but I try to make this like almost cursive in a way, the I, okay? I make it a little bit more pronounced than just doing this, because a lot of times if you don't see the dot, it looks like a 1. See what I mean? A lot of times it's easier just to make it almost like a cursive I. So it's a little bit easier to discern. Full side note, sorry. All right. Addition, subtraction. I think multiplication, huh? That's the next part. In my notes, I have a word problem with this one. I could display it up here, but my computer crashed every single time I tried. All right, I'm not going to chance it. So instead, I'm just going to show you what the problem comes out to be. Look up my notes online, and you can see what that word problem is. It deals with electrical engineering with AC circuit, okay? But I will give you what the problem is right here. All right, so let's try this one. 1 plus 4i times this complex number, 3 minus 6i. Same thing, parentheses are there just to indicate that they're, complex numbers. And, well, we know what to do here, right? Doesn't this look familiar? It should. A lot of people say FOIL. I say distributive. I think, let me just clear the air right now. Okay, when it comes to FOIL, a lot of math teachers don't like that. And I think students are taken aback, like, why do you hate that word? The only reason why is because FOIL you can't use for every case. What do I mean by that? Well, look at this. If I had 1 plus x here, and over here I had x cubed plus x to the 4th plus x squared plus 2x minus 7. Nope. FOIL's not going to work, right? You're going to have to distribute this 1 to everything and this x to everything and come up with an answer. That's why most math teachers are just kind of against that word. All right, so don't get upset if they say you can't use that word. That's just why. All right, let's multiply the 1 to both of these terms here. 1 times 3 is 3. 1 times negative 6 is negative 6i. Sorry, I forgot to include I when I said that. 4i times 3 is plus 12i. And then 4i times negative 6i. Treat this as two different things. 4 times negative 6 is negative 24. I times I is I squared. Please be careful. I think the most common mistake that I've seen with students, you forget that I times I is I squared. A lot of times I've seen just I. All right? Be careful. Combine like terms. Now, 3 is going to stay the way it is, right? I'm not going to be able to do nothing with it as of now. Negative 6i and 12i, when I add those together, I get plus 6i, just like that. And then for the last part, negative 24i squared. Now, going back to the first lesson, we talked about how I squared is negative 1, okay? So down here, if I plug negative 1 into here, I get negative 1 times negative 24, which gives me a positive 24. What do you think? So far, so good? Yeah, thumbs up. Come on, give me a thumbs up. I can't see it. Thank you very much. Last step, combine more like terms. We're not done. 3 plus 24. I'm out of space. I'm going to write it over here if that's okay. 3 plus 24 is 27 plus 6i. And there's my final answer. All right? What do you think? Questions? Not too bad of a concept. Be careful. If this was an I squared and you end up getting like an I cubed, that's fine, okay? What I've been dealing with is I squareds because that's, in most cases, I squared is very common to see when you're simplifying. But you could get an I to the 4th. You could get an I cubed. And you're just going to substitute what those numbers are into this guy, okay? So don't be panicky if you do see that. It's okay, honest. Since multiplication is, I don't know, maybe the next step up for difficulty, I'm going to do one more. Just one more. Come on, you could do one more with me, right? Here we go. All right. another example. 1 minus 3i, 3 plus 2i. And I would encourage you to try this one out on your own before you see me work it out, okay? I'm going to go ahead and distribute. 1 times 3 is 3. 1 times 2i is 2i, just like that. Now we're going to distribute the negative 3. Negative 3 times 3 is minus 9i. Negative 3i times 2i would be minus 6i squared. Combine some terms. The 3, nothing to combine with yet. 2i minus 7i. Oh, I said the answer. 2i minus 9i is 7i. Over here, I'm going to simplify all together. I squared is negative 1 times negative 6 gives me a positive 6. And then we're going to combine the whole numbers together. We get 9 minus 7i as our final answer. And I don't remember if I said this in the video or not. If I did, stop me, please. Interrupt me. You always put the real part first, then the imaginary. Okay, so you just want to be very clear on that. Could you do this? Could you reverse the I? You could. I don't think it's a huge deal. The only time I could think of it being a huge deal is if there was a square root here or just some other expression going on to where that I could be taken for something different. Just be careful. Err on the side of caution. I would keep it like this. All right. I think we have one more thing to talk about. That's division, huh? And before I talked about division, we need to talk about conjugates. Okay? So let's talk about conjugates. What is a conjugate, you ask? I am so happy you asked. You're such a good student. A conjugate, it's not like conjugating verbs or anything like that, okay? Not like an English class, a math class. What you do is you take your complex number. The conjugate would be to change the sign of the imaginary part. If it's positive, it becomes negative. If this is negative to begin with, then it becomes positive. This is the conjugate. Okay? You're just changing the sign. Why is that important? Well, first off, you know in mathematics we have to have names for things, even if it's something this small. But it's pretty important when it comes to division. Okay? We want to get rid of an I that's in the denominator. We want to make this easier to work with in the future. Conjugates are going to be pretty critical. Now, let's flesh this out with an example first. Okay? Let's do this one. Okay? All right. Now, if I want to divide this, I'm going to use the conjugate. Here's the deal. I don't want to work with an imaginary or a complex number here in the denominator, okay? It could be difficult for future calculations, and to be perfectly honest, if you think about what a fraction represents, part over a whole, can you take a whole out of something that has an imaginary component? Probably not, okay? It's a little bit more difficult. Just like this guy right here. Okay, when your math teacher showed you this, they're like, oh my gosh, you can't have a square root at the bottom? That's nuts, that's crazy. It's not that bad. Shh, be quiet. But here's the deal. Square root of 2 is irrational, right? It goes on forever. Can you take one part of something out of something that never ends? Not really. I mean, you could, but if it never ends, you don't know what you're left with. Unlike the fraction 3/4, right? You're taking 3 out of 4 parts. That makes sense. So you would have to rationalize this, right? Multiply top and bottom by the square root. Well, we're going to do the same thing here, but we're going to multiply by the conjugate to make this right. So let's go ahead and do that. So 3 minus 2i is the conjugate for this denominator. Okay, and we're going to multiply top and bottom by it. Here's where a lot of people get kind of mixed up. They're like, well, wait a minute. Is that a legal move? Well, technically it is, because think of it this way. This fraction, if I divide it, isn't it just 1? Technically, I'm multiplying this by 1. So I'm not really doing anything that's like illegal. Okay, I'm multiplying by 1 essentially. Multiply the numerator. So 5i times 3 is 15i. And then 5i times negative 2i would be negative 10i squared. If you recognize this, I don't know if you do, but if you did, oh, that's so awesome. Okay, that's exciting. This is like a difference of square type problem in a way. See how they're both the same factors, essentially? The only difference is what? One has a plus sign, one has a negative sign. When I were to, multiply these guys out, the middle term is going to cancel. And all I'm left with is 3 squared and negative 2i squared, the whole thing, quantity squared. If you don't see that, that's okay. You can still multiply this out fully. Okay? So 3 times 3 is 9. 3 times negative 2i is minus 6i. 2i times 3 is a positive 6i. And then 2i times negative 2i is minus 4i squared. We went from something that was basic to now it's like, oh my gosh, there's a lot going on here. But that's okay. We can simplify this. Just take each part, look at the numerator. Let's simplify that. So 15i, I can't simplify further. A lot of people like putting square root of negative 1 in there. No, don't. Okay? That has a symbol. Putting square root of negative 1 is not simplifying it. Now, I squared I could see in this next part. We know what I squared is. That's negative 1. If I'm multiplying it by negative 10, I get a positive 10 there. Okay? Now look at the denominator. 9, I'm going to bring down. I have nothing to combine with it yet. See how the middle term cancels? Plus 6i minus 6i? I don't have to worry about that. That's why we're multiplying by what's called the conjugate. We're getting rid of that imaginary component that would be left over. Okay? That's why we don't multiply by 2i, or plus 2i. Over here, negative 4i squared. We know I squared is negative 1 times negative 4, which means it's going to be a positive 4. All right? Just combining some stuff together. I'm going to put 10 first, then 15i. Okay? It's just keeping in line with our notation for complex numbers, right? The real number always comes first. That's all I'm doing here. And on the bottom, we have a 13. Now, you would say, I'm done, Mr. McCall. There's nothing else I got to do. I'm good to go. I'll be like, yeah, you're right. This is a good answer. But you could write this a little bit differently. In fact, you can write it truly in this format by breaking up this fraction. So here's the other way we can do it. If we break up the first fraction, we get 10 over 13. The second fraction would be plus 15 over 13 with an I stuck on the very end. These mean the same thing. I'm just breaking this fraction down to where it looks like this format for complex numbers. The real part, which is A, the imaginary part, which is B. All right? Any questions on that? So when you see a problem like this, you're going to multiply what's called the conjugate, and we're 19 minutes in. Man, time flies. And you're going to go ahead and multiply both of these and get your result after you're done simplifying. Okay? One more. Come on, one more. Please, please, one more, and I promise I'll be done. One more. I don't know. Hopefully you're enjoying this. This is a cool realm to be in. And then, wait till we rework the number diagram here. You're going to like this. Okay, last example. 5 plus I over 2i. Okay. Once again, I don't want I in the denominator. I want to get rid of it. But I don't really have a conjugate here, right? Conjugate only works with complex numbers. My denominator is only imaginary. So how do I get rid of that? Well, to get rid of that 2i, why don't we multiply top and bottom by I, right? Think about this ahead of time, just a little bit. If I multiply the bottom by this, do I get an imaginary as a result, or do I get a real number as a result? I get a real number. That's great. That's what I want. I want a real number in the denominator. Okay? That way I can use that for future calculations. Makes it a lot easier. Okay? So in the numerator, I get 5i plus I squared. And then in the denominator, I get 2i squared. For now, until we simplify. The numerator becomes 5i minus 1, because that's what I squared is, right? Negative 1. And on the bottom, I squared is negative 1 times 2, which gives me a negative 2. Last step, divide them, right? Like split them up. Now here's what I'm going to do. Hopefully you're okay with this. I'm going to put the real part first, right? So I'm going to put negative a half, which is another negative a half. It becomes positive, to be honest. So I'm going to put a positive half first, and then I'm going to put minus 5 over 2i afterwards. Okay? That's how I'm going to split them up. I flip this to the first part, that's all. Because the 1 and 2 are both negative, it becomes positive. And then I can use this for other calculations. Okay? Which is great. What do you think? Pretty cool, huh? All right, grand finale. You ready? So, if this has a real and imaginary component, then that means all of our numbers are complex numbers by definition, huh? Here's my diagram. So here's complex numbers. Okay? The symbol for complex numbers, I don't know if I mentioned it in lesson 1. I can't remember that part 1, but it's a C. And they put this little bar here to make it more prominent, but it's C. We have all these numbers, which are the real numbers. And then we have all these numbers here, which are the imaginaries. Complex numbers encompasses all of them. Now you're probably thinking, wait a minute, Mr. McCullough, 5 is not a complex number. It can be written as one. 5 plus 0i. The imaginary part just has to be 0, but it can be written as such, right? Or you could have 0 plus 5i, where you only have imaginaries. Or you can combine them. 4 plus 6i, right? Put them together, real and imaginary. You've been working in the complex numbers region your whole math career. That's insane. And all those math teachers from elementary school to your current class in high school, they've been lying to you, saying everything was real numbers. But it really was just a part of the complex number area, huh? And of course, I jest a little bit, but it's kind of cool that we can rework this. And now, here's what we're doing. Okay? That's it. That is everything. Complex numbers, a lot going on there. So I apologize for the second part being, 20-some minutes long, but a lot of good stuff there. Hopefully that helps you a little bit. My notes online have more examples if you need some more practice with it. But other than that, we're done. So have a good day, guys, and I will see you in the next lesson.